Okay guys, so I'm going to do a video going over the proportional, non-proportional. I'm going to try and record my lesson in class as well and post that so that you can see it as well to kind of maybe help you a little bit better. What we're going to look at is we are going to look at 3 different situations. We're going to look at a word problem and compare and contrast that, a table, and then we're going to also look at graphs. So if it says that Hillary back up here. So Hillary is looking to join a gym. Gym A offers a membership of $25 a month with no sign-up fee. And then Gym B offers a membership for $20 a month with $10 sign-up fee. So I don't want you to freak out because this is maybe something that looks a little bit different. You're used to writing expressions from word problems. So this is exactly what we were kind of doing. We're just going to use it in a different way this time instead of trying to solve. Instead of making them equal and trying to solve, we're going to do something a little bit different. So obviously, like always, my unknown is the number of months that she is going to go to the gym. So if I go to write this, I know that it is going to be $25 per month. And then Gym B is $20 a month. And then that one-time $10 sign-up fee. So if you kind of look at those two, you can kind of determine that one of them we are adding a constant and the other one we aren't. So when we're looking at proportional versus non-proportional, when we have a proportional situation, that is like y equals kx. That's for our proportional situation. For our non-proportional situation, you may remember y equals mx plus b. Notice that even though that k and m are different letters, they're kind of set up the same way, being attached to our variable x. But if you notice, the proportional situation, we're not adding on a constant, whereas with the non-proportional situation, we are. So if we were wanting to identify which one would be proportional, when we're looking at the equation, we know that Gym A would be the proportional one because it doesn't have that initial sign-up fee or that constant. So Gym A, because there's no sign-up fee, or in other words, a constant. So if we go to make a table with those two situations, we know Gym A is 25x and Gym B is 20x plus 10. So if I go and do 25 times 0, just like if I substituted that 0 in, it would give me 0. If I did 25 times 1, it would be 25. 25 times 2 would be 50, and so on. If I did Gym B, I would basically be doing 20 times 0 plus 10. So 20 times 0 would be 0, but plus 10 would give me a 10. So 20 times 1 plus 10 would be 30. 20 times 2 plus 10 would be 50. And so on. So if you notice, when I'm looking at my two tables, which you've seen a lot of this stuff before. You saw it was pre-corona. You've seen a lot of this stuff before. So when I'm looking at my tables, I know that there's a constant rate of change. And when I say constant rate of change, when I am going from the 0 to 1, I increase by 25. I increase by 25. I increase by 25. This one, I increase by 20, I increase by 20, I increase by 20. So they both have a constant rate of change. However, when I'm looking at this and I'm trying to decipher the difference, at Gym A, when I have 0 months, it costs me $0. With Gym B, when I have 0 months, it costs me $10. So when I'm looking at when a table is proportional, and I'm going to show you another way to show when a table is proportional, but one way to determine if a table is proportional or not is that when it is 0, when your x is 0, your y is also 0. So the other way to be able to determine that is to look at the ratio of y. So your ratio of y to x. So for it to be proportional, it has to have a constant ratio of y to x. So basically, if I do 25 divided by 1, it's 25. If I do 50 divided by 2, it's 25. And notice that this is my y value, this is my x from the table right above it. That's my x value. If I do 75 divided by 3, it's 25. However, if I come over here and try to do that, if I do 30 over 1, it's 30. If I do 50 over 2, it's 25. If I do 70 divided by 3, it's 23.3 repeating. So notice that with this one, I have this constant ratio, whereas this one, I do not have a constant ratio of y to x. So for something to be proportional, for example, this would be my proportional one. This would be my non-proportional one. So for something to be proportional, it has to have a constant ratio of y to x. And you can check that, of course, by doing y divided by x. Now, the last thing is if we have our graph of these. So if I go ahead and graph my tables from right above here, when I have 0 months, it costs me $0. When I have 1 month, it costs me $25. 2 months cost me $50. 3 months cost me $75. And I'm going to try to draw a perfect line through here. That's okay. It's not the best, but you notice that I have a line. Well, let's undo that because that's not really what I'm wanting. Let's try this again. Oh, that one's much better. Okay, so I have this line going on my graph. So if I go and do my other graph now for Gym B, instead of starting, when I'm at 0 months, it's going to cost me $10. So I'm starting at a little bit different of a place this time. When it's 1 month, it costs me $30. When it's 2 months, it costs me $50. 3 months, it costs me $70. So if I go to draw that line, when I'm looking at the difference, of these two graphs, you may notice that one of them goes through what we call the origin, and this one does not go through the origin. So when I'm looking at trying to determine if a graph is proportional or not, it has to meet 2 criteria. It has to go through the origin, which is 0, 0, and it has to be linear. And you may remember what linear means, you may not, but linear means a straight line. So in this case, both of these are a straight line. Where Gym B misses out is that it is not going through the origin. So for Gym A would be our proportional one because it goes through the origin and it is linear. It has to meet both criteria for it to work. So if we look at the examples that are down here, for example, number 4. If you remember back up here, we said for it to be proportional, it had to meet y equals kx. I'm not adding on that constant. So if you notice, I'm not adding on a constant here. It would be like, even if I added on plus 0, that would still be y is equal to 8 over 7x. So don't get fooled because sometimes they try to trick you by saying plus 0. Just know that if you add 0 on anything, it's not really changing anything. So y equals 8 over 7x. So that matches y equals kx, which is proportional. Because I am not having, I don't have that constant on there. Now, when you have a table, notice that this table doesn't have 0 on here as my x value. So when it doesn't have that, I have to check the ratio of y over x. So you basically do that by going and doing 13.5 divided by -9, which gives you a -1.5. 12 divided by a -8, which gives me a -1.5. 10.5 divided by a -7, which is -1.5. And 9 divided by a -6, which gives me a -1.5. So notice that each one of these, I have the same ratio whenever I simplify them down. And because I have the same ratio, that makes this a proportional situation. Now, when I look at number 6, remember when we have a graph, it has to go through the origin and be linear. And remember, your origin is at 0, 0. So notice how number 6 does not go through the origin. That makes it non-proportional because it does not go through the origin. Sorry, my dog is having an issue. Then, so if I write the expression for number 7, it is 99 cents for each balloon plus 2.79 for shipping. So that would be like y is equal to 2.99 cents x plus 279. I have this constant on here, which would cause it to be non-proportional because that matches that y equals mx plus b, making it not proportional. Now, when I'm looking at number 8, remember, again, your graph has to go through the origin and be linear, and linear means a straight line. So when I'm looking at number 8, it does go through the origin, but do you notice how it is not a straight line? So because it is not linear, it is not proportional because it is not linear. And if you wanted to put on number 6, it doesn't go through origin. It has to meet both criteria for it to be proportional. Now for number 9, again, we have to check that ratio of y to x. So I'm going to do 18 over 8, which gives me 2.25. I'm going to do 20 over 10, which gives me 2. So already I know that this is going to be a non-proportional situation because it doesn't have a constant rate of change. It doesn't have that constant ratio. So I don't even have to continue because I know that it is going to be non-proportional because it does not have a constant of proportionality or a constant rate of change, kind of the same thing. So what I have also, there's also going to be another document for you to look at that is just looking at it mathematically, that kind of has examples of proportional, non-proportional. So I will have that linked as well for you to check out.